resource. Only about 1% of all the water on Earth is in lakes. 0.01% is in rivers. Yet, we absolutely require it, as was stated earlier. For this reason, most major cities are based on water, where water is. You know, why is St. Louis where it is? Well, it's because that's where two rivers come together. Come on, you gotta know your geography better than that. What two rivers meet in St. Louis? The Mississippi, yeah. And the Missouri, correct, yes. Why is Kansas City where it is? Kansas River and Missouri River, right? I mean, you just start looking at cities and almost all of them are based on something like that. I mean, even Denver is where the Platte River comes out of the mountains, so there's a reliable source of water. You know, even places you don't think of being that way. So we put an incredible amount of pressure on this very small amount of total water. U.S. water use, we use about 2,000 cubic meters per year, per person per year, right? 2,000 cubic meters per person per year is like the size of this room. You know, it's quite a big amount of water. Much of this water use is for industry and irrigation, not just home use. So there's an economic value of water for industry. There's an economic value of water for growing our crops, right? And what's the major source of irrigation water for our state? Aquifer, yeah. Yeah, you got it. Ogallala or the High Plains Aquifer, right. You know, and these center pivots you can see them from space, and they're a huge economic engine for us. But you need to keep that water in good shape to be able to use it for these. Surface water provides most of the water, but more and more groundwater is being used. So there's this huge demand for it. As human population grows, that demand also increases. So this is just an example of water use from 1950 to the year 2000. And we can see that, and then this is in the textbook, so you're gonna, I should mention that you should always be able to read and reproduce graphs. I'll tell you which ones I want you to be able to do verbatim. But it's a very valuable skill to learn because I can put more information across in a graph quickly than I could ever in words. And so if you're having trouble with that, and we're going to have some peculiar ones in this class, you'll have to learn how to do that. So on the x-axis, we're going from 1950 to 2000. On the y-axis, we've got the U.S. population, right? That's gone up pretty dramatically and continues to climb. And the per capita water use, it actually peaked out in about 1970, and then we actually started getting more efficient with our water per person. And we're almost back down to where we were in 1950. But we're still using quite a bit. And then on the top panel shows that of the total withdrawals, the domestic is a very small portion of that, right? And that agriculture and industrial, the next two lines up, and then you sum everything together and you get the total amount that we've been using. But because even though our efficiencies increased, right, our use per capita is less, the population has grown, we have more capitas, right, more per capitas, and so the total use has continued to go up. Or at least it's a little bit flattened, but. And this is a global water use per year from the 1800s, so over the last 200 years for everybody on Earth. And you can see that this is an exponential increase. And that's because of two reasons. One, human population has increased exponentially. And two, the rate that people use water has increased substantially. So as we move into more developed countries, people use more water per capita per year. Right? So those two things are driving increased water use. What it turns out is that the current global water use is at about half of the water that is temporally and spatially available. Of the half of the fresh water that's available. So we have a rate through the hydrologic cycle that water's being produced, right, for us to use. We're currently appropriating half that. Okay, so what do I mean by spatially and temporally available, over space and time? What can you think of water that's not available over space for human uses? That there's fresh water that we just can't use. Pardon? Ice, yeah, glaciers would be one thing. What else?
Seawater.
Seawater, that's correct. But the seawater is not included in this, and there's good reasons for that, because it's very energetically expensive to purify it, one, and move it, two. Water's really heavy, so it costs a lot of energy to move it from the ocean up to, say, Kansas. People tend not to move it. Okay, what else?
Groundwater?
Yeah, it might not be available to us. That's true. Any of the really large rivers, like the Amazon, for example, there's just not so much population that can use it. So a lot of the water just kind of flows by us. Or the water in the large rivers in Canada, there's just not population there. You can't use that fresh water, right? But of the stuff that's available to us, humanity now uses about half. What do I mean about availability over time? Can you think of a reason why we might not be able to use some water that is there, fresh water that's there? It happens in conditions that are exactly the opposite of the hydrologic conditions of this year.
Clouds, rain.
Rain, yeah, but what about rain? I mean, all of it comes from rain, so why is it, what happens sometimes that makes it so we can't use water, that we miss the opportunity to use water? Yeah?
Pollution, like acid rain?
Pollution does somewhat, yes.
Floods?
Floods, yeah. Floods. I mean, if, in 1993, we had a massive amount of water come through here, right? And you can't catch it. You can't, if there's so much water, you just can't get it. So that's temporarily available. Now you can add on to that the things like pollution, where we're making water unusable and making less and less available to us, and that's becoming more of an issue as well. Okay. So what the point I'm trying to get across to you is it's a very important resource. And it turns out that the world market for water is about to exceed the value of the world market for oil and fossil fuels right now. Okay. So it's incredibly important economically in a global sense. So I made this point about 30,000 cubic kilometers per year, only 9,000 total of all that water that's flowing across the land, fresh water, is available. And we're using about half of that water. Okay. If everybody on Earth used water at the rate we do here in the US, right now, the current population, there would be no water left, essentially, for other uses. So the fish that you like so would have nowhere to live, basically, right? So we're really pushing up against a finite resource, and you brought that point up very early on in this lecture. It's a good point. As countries develop and as population increases, the pressures will rise on water resources. So it's very important to understand water, its quality, its availability, and its characteristics, right? Because it has very important value to humanity. We can't survive without it. And we listed the values already. So we've done these accounting things and come up with values for water, and they put all the values of the ecosystem, goods, and services, right? The things water does for us and the products that it produces, and total those up. And you can do that a variety of different ways. So one way that water quality is valuable to us is that it cleans up our waste, right? So historically, we dumped all of our waste just into the Kansas River here without any treatment. All the sewage went there without any treatment. because we overwhelmed the capacity of that system, and, you know, Wamego and Topeka and Lawrence and all the cities overwhelmed the capacity of that river to deal with it. The Kansas River was in horrible shape. It was basically, you couldn't go in it. It was going anoxic. Many rivers in the United States were in the exact same situation. And so they regulated how much sewage you could dump in, what condition that sewage was in there. Well, it costs money to build a sewage treatment plant, right? So that's a value of the water that we took away, and then we had to reinvest elsewhere and make it, and basically create value for that. Some other values we talked about, you know, you can put monetary value on fish. You can put monetary value on recreation, right? People spend to catch fish or to just go canoeing on a river, rafting, all of those things. Water also then has the economic value we talked about with irrigation and about use for industry. There's also aspects of aquatic ecosystems that are important in terms of keeping damage from happening or providing us water. So for example, maintaining a good forest makes water available in a constant fashion because the runoff is consistent. You have less likely floods, the droughts are less severe, right? So it's all tied together, and the value of water is one way, the value of these ecosystem goods and services associated with water is one way to put value to humanity there. Okay. One thing that's missing, there's a really important thing that's missing. Can anybody come up with that? With this whole approach of assigning value to any ecosystem good and service. What's a very key issue that's missing?
You can't place a value on some of these things once they're gone.
Yeah, great. I mean, there's another part of the values called cultural values. What value do we put on these that doesn't have a monetary value, right? I mean, a lake could be sacred to you. Many of the people in this class just love to go out and fish, not necessarily because they're catching the fish, but because of the experience of being out, you know, in the wild and seeing biodiversity. Unfortunately, most people around don't care if, say, the Topeka shiner goes extinct, right? But being biophilic, that is loving animals and diversity, somehow we feel the world is diminished because of that. There's no monetary value you can actually put on that, other than the fact that by law you have to protect it, and then it gets assigned monetary value. Because of our cultural desire to protect that